All right, so we've technically started part of 9.2 when we were graphing complex numbers. So now we're going to learn different ways we can write complex numbers. Typically, we write them in the form a plus bi, right? Where a is the real part, b is the imaginary part. We can also write them in what is called their trigonometric form. And those look like r cosine theta plus Ri sine theta. So there's actually a really easy way to go back and forth between these two things. So to find r, you use r squared equals a squared plus b squared. All right, and then to find theta, you're going to use inverse tangent of b over a. So let's do an example. Let's say our complex number is -3 minus 4i. So a squared plus b squared. So 9 plus 16. So 25 is r squared. So that means r would be 5. Right, then in the calculator, you're going to do inverse tangent of -4 over -3. Right, and so that ends up giving us roughly 53 degrees. So to write this in its trig form, you would do 5 cosine 53 plus 5i sine 53. And that's it. You just have to write it that way. That is all. And if you needed to put it back in complex form, you would simply just plug this in the calculator and find what 5 times cosine of 53 is, and then what 5 times sine of 53 is, and stick the I on it to get it back in this a plus bi form. All right, this is pretty straightforward. This should be enough to get you through the assignment that we will do tomorrow. All right, so you guys don't have to do an assignment today. You just need to take notes on this video. Please post your notes on LMS so I know that you've watched the video and taken notes. And let me know if you have any questions. All right, so we're going to learn how to find the areas of all the other quadrilaterals we learned about in the last chapter, in the last chapter. So the first one we're going to do is a trapezoid. So the area of a trapezoid is the height times the sum of the bases divided by 2. So let's see what that's going to look like. That's a very ugly trapezoid I just drew. All right, so your bases are here and here. Right, you're going to add those together first before you would multiply by your height. Now, remember, height is not a slanty side. Your height will always make a right angle. Right, so if you have a trapezoid that looks like this, right, where you've got that right angle, in that case, this would be your height, okay? If that forms a right angle here. All right, so does everybody see what those sides are? Okay, so let's do an example. Somebody give me a number.
27. 45.
Ew.
27.
45.
10. 75.
I like 10. We're talking quick to add and multiply numbers, guys.
198.
All right. 10, 5. Give me another number. Bigger than 10.
8. Oh.
198.
17.
17? We have to divide by 2, people.
14.
14, sure. Okay, so You all are terrible number pickers. I'm going to have to do that on my own from now on. All right, so our height is what? 5. And then 10 plus 14. And then the last thing we will do is divide by 2. Oh, sorry. All right, so 10 plus 14 is? 24. So we're going to multiply the 5 and the 24 and then divide by 2. 5, 12, 6. So 120 over 2, which is 60. Right? So remember, order of operations, you're going to add first, then multiply, then divide. Okay? All right, is everybody with me on how to do trapezoids? Okay. I mean, that's okay if you're not, if you're still writing. I'm just trying to make sure that you guys understand what's happening. Okay. So now we're going to learn about kites. So the area of a kite is diagonal 1 times diagonal 2 divided by 2. So, not on this part. We did other shapes yesterday. Yesterday we did square, rectangle, triangle, parallelogram. What? What is happening? All right. Shh. Cares. It is, but stop. All right. So diagonal 1. Diagonal 2. It really doesn't matter which one is which because you're multiplying them together anyway. So a lot of times for the kite, the pictures are going to kind of give it to you in pieces. So like they would say like this piece is 11 and this piece is 11. So you're going to have to add those up to know that your diagonal 1 is equal to what? What's 11 plus 11?
22.
Yeah. Right, so just because the way they're drawn, it's easier to do it, like give it to you in 2 pieces. So diagonal 1 in this case would be 22. Then they would give you, I don't know, let's say this piece is 13 and this piece is 30. So again, you would have to add those together to get diagonal 2. So that would be 43. All right, did everybody see what I did?
Yeah.
All right, a lot of times you're going to have to add those pieces together before you multiply. All right, so I added 13 and 30 because the 2 pieces of the green one. Yeah. And then now we will take these 2 numbers, multiply them together, and then divide by 2. So we'll have 22 times 43. What?
Oh, nothing.
Okay. So the 22 times 43 gives us 946. And then divide that by 2, which gives you an area of 473. Uh-huh. All right, so there are 2 ways you can find the area of a rhombus. It's going to depend on what information is given to you. So, first one is base times height. Right, because a rhombus is basically, well, it is a parallelogram with 4 congruent sides. Right, so, again, you have base and our perpendicular height. Because remember, height is never what? Right, it's never not a right angle or never slanty, right? No slanty sides or height. It also can be diagonal 1 times diagonal 2 over 2, just like it was for the kite. So again, it depends on what information you have in your picture. So diagonal 1, diagonal 2. Right, and so a lot of times for a rhombus, they're just going to give you like that one is 4 and this one is 3. But remember, they bisect each other. So this would be 3 and this would be 4. So you have to use what we learned in the last chapter for some of these to make sure you have all the parts. Right, so you know that these are going to be congruent. So if it only gives you 1, the other one's going to be the same. Same thing here. Those two would be congruent. So the length of diagonal 1, which is the blue one, would be what? 6. The length of diagonal 2, which is yellow, would be 8. So 6 times 8 is 48. Divide that by 2. Your area would be 24. So again, for this one, it doesn't matter what formula you use, but you need to make sure that you're using the one that makes sense with the information you have. So if you have a base and height, it's obviously not going to make sense to do this. Right? If you have diagonals, you're going to want to use this one. So they can give it to you. Either way, you just need to look and recognize what you have to choose the right formula. Okay, any questions on these formulas so far? Okay. All right, so your assignment today is page 308. We're going to do 1 through 7 and 11 through 14.